Calculus is a branch of mathematics developed by Sir Isaac Newton, the greatest physicist. He realized to deal with rate of change of a quantity with respect to another quantity, a new branch of math is needed. In physics, we will come across physical quantities. For example, x, so displacement, is a function of time. When time changes, displacement is changing. So, rate of change of displacement with respect to time is called velocity. Rate of change of velocity is acceleration. Then, a quantity y can be expressed as a function of x. When x changes, y changes. Here y is called dependent variable, x is called independent variable. Then value of y depends on the value of x. Suppose x changes by a small amount delta x. So x plus delta x. Then y will change by a small amount delta y. Take this y to the other side. So you will get a delta y. Delta y is equal to f of x plus delta x minus y. Then both sides you divide by delta x. So you will get a delta y by delta x, where delta y is the small change in y. Delta x is the small change in x. Now limit delta x tends to 0. That means change in x is very, very small. It is not 0. If delta x is 0, change in x is 0, so change in y also will be 0. So it will be 0 by 0. It is indeterminate. So here meaning is change in x is very, very small. Delta x tends to 0. In the limit delta x tends to 0, delta y by delta x is dy by dx. Now limit delta x tends to 0, this is known as dy by dx. So f of x plus delta x minus f of x. So this is the change in y. Then delta x is tending to 0. Then this is what's called dy by dx. It's called derivative of y with respect to x, dy by dx, the rate of change of y with respect to x. Now I will explain this with an example. Let us try to understand the meaning of differential coefficient. Y is a function of x. Now let it be x square. Y is equal to x square. When x is going on changing, value of y will be changing. At first, let value of x be 2. Let us give it x1. x1 is 2. x2 is 3. Now when x1 is 2, that means x is 2. Y is 4 because 2 square is 4. So x1 is 2, y1 is 4. Now x changes and its value is 3. At that time value of y is 9. When x is changing from 2 to 3, y is changing from 4 to 9. Now change in x, that is delta x. From this you minus this, x2 minus x1. That means 3 minus 2. 3 minus 2 is 1. Next, delta y. Delta y, change in y, that is y2 minus y1, that is 9 minus 4. 9 minus 4 is 5. Now delta y by delta x, change in y divided by change in x. Delta y is 5. Change in x, delta x is 1. 5 divided by 1 is 5. At first we have taken x1 to x, value of x is 2. Value of x is changing from 2 to 3. Next, again you take x2, but instead of 3, now you take 2.5. So we are coming closer to 2. At first 3, next 2.5. So we are coming closer to 2. When x is 2, y is 4, that is y1 is 4. When x2 is 2.5, y2 is 6.25. Again you calculate delta y by delta x. Change in y, y2 minus y1, that is 6.25 minus 4, that is 2.25. Change in x, delta x, that is x2 minus x1, that is 2.5 minus 2, that is 0.5. So when you divide this 2.25 by 0.5, it is 4.5. So now change in x is going on decreasing. At first it was 1, now it is 0.5. So at that time delta y by delta is approaching 4. You can see 5 next to 4.5. Now you take a little more closer value, 2.25. So when x is 2, y is 4, then x is 2.25, this square, y is x square, so square of this is 5.0625. Again you calculate delta y by delta x, delta y, change in y, from this you minus this, you will get this, then delta x, from this you minus this, you will get this, then delta y by delta x. When you divide, you will get to 4.25. Again you take a little more closer value, instead of 2.25, so we have taken x2, 2, again x2, then take a closer value, 2.1, 4, 2.1 square is 4.41. Again you calculate delta y by delta x, delta y, change in y, from this you minus this, so 0.41 divided by 0.1, from this you minus, so 0.1. So when you divide 4.1, from this is clear, when delta x is going on approaching 0, first it was 1, next 0.5, next 0.25, next 0.1, that means delta x is going on approaching 0. This we can say limit delta x tends to 0, not 0, tends to 0. So you can see it's a very small. Then this delta y by delta x is dy by dx. So you are going on decreasing the change in x, delta change in x. So now here it is 0.1. So this process can be continued, and limit delta x tends to 0. This delta y by delta will approach 4. So using the concept of limits, dy by dx is 4. When x is 2, differential coefficient of y with respect to x is 4. Now I have explained how to get dy by dx when x is 2. Rate of change of y with respect to x when x is 2. Now we'll see generally y is equal to x square. Suppose x changes by a small amount, delta x, so x plus delta x whole square instead of x square. At the time y changes by a small amount, delta y, so instead of y, y plus delta y. Now it's a square, x plus delta x whole square. It is of the form a plus b whole square, so a square plus 2ab plus b square. So we can expand this, x square plus 2x delta x plus delta x square. Now delta y is the change in y. Take this y to the other side, so you'll get a delta y, but y is x square. So this y, when you take to the other side, minus y, but y we can write x square. Now you divide both sides by delta x, delta y by delta x. Then this x square minus x square, so it will get cancelled. So you will get 2x delta x plus delta x square. Now 2x delta x, this delta x, so delta x will get cancelled, so 2x plus delta x square, then delta x, 1 delta x will get cancelled, so plus delta x. Next, limit delta x tends to 0. That means delta x is becoming very small. It is tends to 0. Then this ratio delta y by delta x is known as dy by dx. So the differential coefficient of y with respect to x. When delta x tends to 0, that is delta x is very small, so it's negligible. So this delta x can be neglected, so you will get to 2x. So derivative of x square is 2x. When y is equal to x square, derivative is 2x. Then last example, x was 2, so if you put 2 into 2, 4, so dy by dx is 4 when x is 2. Then generally y is equal to x raised to n. Here y is equal to x square. At that time 2 is coming in front and the power is reduced by 1. Then 2 is becoming 1. So generally dy by dx is equal to, when y is equal to x raised to n, it will be n x raised to n minus 1. So this is the derivative or differential coefficient of y with respect to x when y is equal to x raised to n. When y is equal to x raised to n, dy by dx is n x raised to n minus 1. Suppose y is equal to x, that means n is 1. Then dy by dx. So instead of this y, you can put x. So dx by dx, so it's 1. Numerator and denominator same. So dx by dx is 1. But you can get from this formula also, because in this example n is 1. So 1 into x raised to n minus 1. Here n is 1. So 1 minus 1 is 0. Any number raised to 0 is 1. So it's 1. So when y is equal to x, dy by dx is 1. Suppose y is equal to x cube. Then as per this formula, power is to be brought in front. So 3. Then power is to be reduced by 1. So n minus 1. So it will be 2. So 3x square. Derivative of x cube is 3x square. Now y is equal to sin x. Then differential coefficient dy by dx is equal to cos x. Y is equal to cos x. Then differential coefficient dy by dx is minus sin x. Suppose y is a constant. That means y is not at all changing. Y is a constant. Then rate of change of y with respect to x will be 0. That means dy by dx is 0. For when constant, differential coefficient will be 0. Now let us see one example. X is a function of t. X is given to be a0 plus a1t plus a2t square. Now we have to get dx by dt, rate of change of x with respect to t. So now dx by dt. A0 is a constant. So derivative of a constant is 0. Here it is a1t. So you have to write a1 as it is. Derivative of t is 1, dt by dt for this x. Now y is equal to x, then dy by dx is 1. So similarly, derivative of t is 1. So a1 plus a2, you have to write, then t square, derivative of t square is 2t. 2 will come in front, then power is to be reduced by 1. So derivative of a constant, when that constant alone is there, it will be 0. Otherwise, that is to be written, then derivative. Next, dx by dt is equal to a1 plus 2a2t. So this is the first derivative. Second derivative, that is d square x by dt square. Again, this is to be differentiated. So a1, derivative of a constant is 0. 2 constant, a2 constant, then derivative of t is 1. Thank you for watching.